Some thunderstorms pop up, drop rain, and fade within half an hour. Others organize into long-lived weather machines that can damage suburbs, farms, and highways across a whole district. In Australia, the Bureau of Meteorology warns for severe thunderstorms when a storm is expected to produce large hail, damaging wind gusts, tornadoes, or heavy rain that may lead to flash flooding. The warning is about the hazard, not just the presence of thunder and lightning. Forecasters use radar, satellite, observations, and reports to judge whether a storm is intensifying, moving toward people, or crossing dangerous thresholds. Storm shape depends on four main ingredients: moisture, instability, updraft strength, and wind shear. Instability helps warm air rise. Moisture gives the storm fuel. Wind shear, which is a change in wind speed or direction with height, helps decide whether the storm collapses quickly or stays organized. The simplest type is a single-cell thunderstorm. One updraft builds a tall cloud tower, rain and hail begin to fall, and the downdraft often cuts off the warm inflow that was feeding the storm. Single cells are usually short-lived, but they can still bring dangerous lightning, intense rain, small hail, and sudden damaging downbursts. A multi-cell cluster is a group of storm cells at different stages of life. As one cell weakens, its cool outflow spreads along the ground and lifts nearby warm air, helping a new cell form. That renewal process lets clusters cover a wider area and keep producing heavy rain, hail, and gusty winds for longer than a single cell. Squall lines are long, organized lines of thunderstorms, often forming along fronts, troughs, or sharp boundaries between air masses. Their main danger is a fast-moving burst of wind, heavy rain, and frequent lightning along the leading edge. A shelf cloud can mark that gust front, and because the line is long, many towns can be hit in quick succession. Supercells are the most organized severe storms. Their key feature is a rotating updraft called a mesocyclone. Rotation helps separate the inflow from the rain-cooled outflow, so the storm can keep feeding itself. Supercells can produce giant hail, which means hail greater than 5 centimeters across, damaging winds, intense rainfall, and sometimes tornadoes. On radar, a supercell may show a hook echo, a curved shape that can suggest rotation, but ground reports and other data are still needed. Mesoscale convective systems are much larger storm complexes that behave like one broad weather system. They can last for hours, spread lightning across the night sky, and bring heavy rain and damaging winds over several districts at once. Australian geography helps decide where these storm types form. The Great Dividing Range can lift warm, moist air and start storms inland of the coast. Sea breezes, inland heat, and moisture boundaries can focus low-level convergence, especially when humid air meets hotter, drier air. In southeast Queensland, low-level jets can feed warm, moist air into storms and strengthen inflow when wind shear and instability are already favourable. To understand the risk, watch the warning area, the storm movement, and the hazard named by bomb. Move indoors early, secure loose items, bring pets inside, keep vehicles under cover if safe, and stay away from windows during hail or severe wind. The storm type helps explain the threat, but your safest move is to act before the core arrives.